All right. So let's start with what we would see if we were to open an exam paper or a test paper, right? So first thing they're going to say is they're going to tell you that you are given f of x is equal to something. Now, this f of x is very important. We need to understand what f of x means in terms of what we've been given. All right, so the f of x means that we are looking at a function named f. The name of the function is f. All right, so we know that the function named f has a particular output or input. That input that we're looking at is the values of 2x minus 5. This is our input. And our function of f in terms of x will give us certain output values. So the input is the function itself, and what we get out is the output, right? But now, when we put this on a Cartesian plane, we know that if you've seen a Cartesian plane, it only comes with two sets of axes. It's going to be our y-axis and our x-axis, just those two, right? So we're going to get an x-axis and we're going to get a y-axis. Now, our x-axis is defined across all real numbers. Let's remember that. X is defined, actually both x and y, we'll say that. Okay, x and y are defined across all real numbers. Now, let's talk about what this means. Okay, what this means is on my x-axis, as it's drawn here, this horizontal line, I can find any real number I can think of. Can you guys give me a number, an example of a real number? I'll start us off. 4, thank you. Sanalisa says 4, lovely. Anyone else? Any other real number?
8.
8, perfect, 8. Okay, I'm going to make it a little bit more spicy and I'm going to say something like negative 1,65. That's a real number, right? And I can also say 5 over 12. 5 over 12 is also a real number. You'd be surprised, the square root of 3. It's an irrational number, but it is contained within the real number system. So on my Cartesian plane, I know I can find the value of the square root of 3. It's somewhere between 0 and 1. I'm going to be able to find the point there. Now, because our x and y is defined in a certain way, we know that x or y is always defined as a function in x. All right, so what that tells me is if I choose any real number value for x, if I choose x to be 4, like Saneliso said, I should get, for that number 4, a corresponding y value as my output. So my input will be the x value, and the y value that I will get out is, or the y value that I'll get out would be my output. So what this tells me is, if I decide if x is equal to 4, then my function f at the x coordinate 4 will give me a specific value for my y. So if I'm going to replace all my x values with 4, I'm going to have the function f at the point 4 is equal to 2 times 4 minus 5. That's going to give us 8 minus 5, which is 3. So that means at the x value 4, I should get a y value of 3. And that's how we define a function. Okay, so if we look at this next example that ma'am has given you over here, I'm going to ask you guys, what is this function over here called? What is the function of this graph? Or what is the name of the function, rather? The first function that we had was named f. What is the name of the second function?
G.
G, beautiful, yes. Okay, so we know that we should be able to excuse me, we should be able to find any values for the graph of G, or the graph of G in terms of my function x. So for whatever x value I choose, let's say, for instance, we choose if x is equal to 1, I should get that my function g at the point 1 will give me a certain value, -3 multiplied by 1 all squared plus 4, right? That would give me -3 plus 4 is going to give us 1. That means for the function g specifically, when my x value is 1, my y value will also be 1. My input will give me 1, and my output will also give me 1. And I just need to double check with everyone. Thumbs up. Do we all know how to represent our x and our y values on a Cartesian plane? Are we familiar with how to do it? I'm happy to show you guys if we don't. I know it was a grade 11 concept, but I'm happy to do it. Okay. Saneliso says thumbs up. The rest of us, how are we doing? Oko says no. Okay, that's fine, Oko. We can do that. I'm happy to explain again. All right, so our function is f of x is equal to 2x minus 5. Okay, so this is our function. F of x is equal to 2x minus 5, right? So whatever value I choose of x will be the input that I insert into the function. Whatever answer I get out will be the output, right? So these two things can be represented. Oh, I will show you again just now, Balisa. All right, these two things put together will give us a certain coordinate on the Cartesian plane that we call x and y values, but they represent the input value and the output that we got for that value. That's what those two values tell us. So if I choose, if x is equal to 4, then I know that the function at the point f would equal 2 times 4 minus 5. Okay, so I know that the function of f at the point 4 has an input of 4, but has an output of 2 times 4 is 8 minus 5 is 3. Okay. Let me try another number. Let me say if x is equal to 0. Let's say if x is equal to 0. Then I know my function f is being defined at the x value 0. And that is going to equal to 2 times 0 minus 5. So that means my output over here would be -5. That tells me on my Cartesian plane, where my x value is 4, my y value will be 3. My input was at the point 4. The output of that function came out at the point 3. Same down here. If my x value or my input was 0, my output value, my y value, was -5. All right, let's see how we represent these two things on a Cartesian plane. But before I do that, Palisa, let's just go back quickly. Have a look here. Here is the function. It says -3x squared plus 4, -3 times 1 squared. 1 squared is just going to give me 1 times -3. That is -3 plus 4. And that's how ma'am got 1. Are we okay with that? Okay. Let me know if that's okay, because that's how I got to the point. Excellent. All right. So let's go to our Cartesian plane and let's represent these two inputs and outputs. Remember, we're going to go to our x coordinate. So our x coordinate always comes first. X first, and then our y value. So first, we're going to go to our x axis. Excuse me. We're going to go to our x-axis, and we're going to look for the point 4. So I know on my x-axis, this is my negative values over here. This is also my negative y values. On my x-axis, +4 would sit there. On my y-axis, my positive y numbers would be above the x-axis. So all my positive y values would be here. So I'm going to say that that is 3. How we're going to represent it is we're going to draw a horizontal line for my y, a vertical line for my x, and here, this point where they intersect, that we call the point or the coordinate 4 and 3. I want us to be very careful, grade 10s. The x coordinate always comes first. We always put input and then we put output. You never swap them around. always x first and y next. Because if I don't choose an x value, I will not get a y value out. I must choose the x value in order to get a y value. Does everybody understand that? If I don't choose an x number, I'm not going to get an answer for y. So the x value on my coordinates or on my Cartesian plane must always come first. Oko, are we okay with that? Right? Let's go ahead and plot the second point. Now, I know that my x coordinate is 0 and my y coordinate is -5. Now, my x coordinate as 0 is right there. That's where it is. And my y coordinate at -5 would be down here. So they're meeting on that straight line. So they're doing that. We're going to meet right there. That's where they would intersect. Okay. Now, what this then tells me, I'm going to make this black quickly, right? What then this tells me is that I have a function that looks like that. Okay. And this then tells me that all the values that I would get along this line would correspond to the function that I've been given. So let's say, for instance, this crosses the graph at 3, right? If this point crosses the graph at 3, right? And that's not going to work, actually. It won't be 2. It would be a fraction. Okay, we won't be able to get it. Okay, let's say, for instance, at the point 3, if this is point 3, the y value would correspond to a point that crosses the graph. If my x value is 1, my y value at that function of 2x minus 5 will cross on that line that we've drawn. It will, all of the functions, all of the values for x will be on this line, or all the y values we get out for our x values would be on this line. So if we decided to go and look where 2 would be, we're going to find that if we input 2 as an x value, our y value would give us a value on the line. If we chose an x value of 5, our y value will give us a code, or a y would be something that would be on the line, would give us a point on the line. All right. If I chose my x to be 6, my y value would be a value that ends up on the line. Same with all my negative numbers. If I chose, let's say, for instance, -1, if I chose -1, my y value would give me something. Okay, the y of 3 is 1. Correct, Saneli. So the y of 3 is 1. So we know that if we choose x to be 3, if x is equal to 3, then we're going to input the value 3, and we're going to get a y value out. So we can say the function at the x value 3 is equal to 2 times 3 minus 5. So 2 times 3 will give us 6, minus 5 is 1. So Saneli, so you're on point. That means if I input the value, the x value 3, my y value that comes out will be 1. And if I extend this horizontally and I extend this vertically, they're going to meet at that exact point on the graph of my function. Okay. Right, thumbs up. Does everybody understand what Ma'am is saying? The corresponding x value will always give us a y value that corresponds to the function that we've been given, the straight line that we've got. All right, just give me a second, guys. Okay, all right, Sia says 50%. I'll show you as we go along, Sia, because we're going to be doing different types of graphs. We're going to be able to figure it out. Okay, so don't stress, it will come up. Okay, so let's look at g of x. All right, so we've spoken about f of x. I'm going to remove it, okay, because g of x is also a little bit interesting. All right, let's talk about g of x in terms of input and output. All right, so if we have a function, it's called g. The name of the function is g, right? I'm going to choose a random value of x that will be defined on g. Sia, do you want to pick a value for me? Pick an x value. Doesn't matter what it is. If x is equal to what? Pick a number. 5. Excellent. So we know that if x is equal to 5, right, our next thing for us to do would be to say g, the graph g at the point 5 will give us a y value of something. Our input is 5. What would our output then be? So that means wherever we see an x, we're going to replace the x with 5. We're going to go -3, open brackets, 5 squared plus 4. Right, let's find that answer. Does anyone have an answer for me? It's a very big number. Thank you, Sia, for that one. It's going to give us a really huge number. Okay. Okay, so it should give us -75 plus 4. Should be looking at something like -71, something crazy like that. Okay. Right, so if we punch that into a calculator, we should get -71 out. Agreed? -71.
Yes, we got negative.
Beautiful. Okay, lovely. So what this then tells us is that at the x coordinate 5, so we go to our x-axis, at the x coordinate of 5, this is -x. Remember, these are all our negative values on this side. Right. At that point, x is equal to 5, our y value would be -75. I'm going to assume it's somewhere like way down there, -71. Right. So we're then going to move in this direction, and then we're going to move in this direction. And at that point where they meet, this tells us that our input was 5 and our output was -71. Okay. So let's say we choose the value x is equal to 3. Let's pick if x is equal to 3. If x is equal to 3, then I know my function g at the point 3 will give me a specific output. So I'm going to go -3, open brackets, 3 squared, all squared, plus 4. Okay. If I do that, then I'm going to find that my value is, we're going to get -27 plus 4. That would give us -23, right? So when x is 3, when x is 3, our y value would be -23. We'll just put it somewhere over there, -23. Then we've got to see where they correspond. They would meet there. Okay. Okay, let's try 0. Let's say if x is equal to 0, then I know that my function g at the point 0 is going to give me -3 times 0 squared plus 4. I know anything multiplied by 0 is going to give us 0. So the answer over here is going to be 4. So my x coordinate will then be 0 and my y coordinate would be 4. My x coordinate at 0 is right there. And my y coordinate at 4 would be somewhere up here, 4. So these two would cross there. All right. Is everybody getting it, Sia? Are you understanding what's happened here, right? The function or the input of one gives us an output on the other side. All right. Okay, now we need to then understand what is considered a function and what is not. Okay, so for us to do this, we need to consider something. Okay, I'm going to move over. I'm realizing I've squeezed too many things in here, and we need to be able to tell if something is a function or not. Okay. And we're going to talk about the domain and range in a little bit more detail as well. All right, let's talk about if something is a function. Now, in order for something to be called a function, like what we were just doing, an example of a function, e.g., would be f of x. That is the function f at the point x, or g of x. They could name it anything, guys. They could also name the function h. h of x, or they could name the function m of x. It doesn't really matter what the function is, right? Now, for this, for any of our graphs, like the straight line that we drew, the way we're going to tell if something is a function is if I have one y value, oh, sorry, one x value for every y value. Okay, one x value, okay, for every y value. Okay. And the way we can do this on a particular graph is if we can do something called a vertical line test. Okay, that's how we're going to test. I'm going to show you guys what it means. Test is called a vertical line test. Write that down, guys. This is in your matric paper. This part, the vertical line test part of your matric paper. So make sure we're understanding what we mean when we say vertical line test. Okay, and I'm going to show you guys an example. Okay, when we look at, just give me 1 second, this thing is being tricky. Okay. Sorry guys, my computer's being funny. My mouse is super, super slow, and I don't know what's going on. Okay, there we go. All right, so here's some examples of functions, right? You don't have to draw them all. We're just going to be testing the idea of a vertical line test, right? So what I'm going to do is I'm going to draw a vertical line, or I can use a ruler. You guys can use a ruler for this. Okay, I'm going to draw a vertical line. It must be an exact vertical line, right? In order for my function to be an actual function, I can only have one x value and one y value at a time, right? So if I move this across, if I put it over there, do I only have one x value and one y value? Yes, I do. My graph is only crossed there, right? If I move this down in this direction, wherever my ruler crosses, do I only have one x value and one y value? Yes. So this is considered a function. Okay, and the reason why we want functions to be defined this way is because functions give us graphs of things like the projected profit that a company will do or will make. So there's no way that I could have a function that says C is equal to 100p. Let's say, for instance, I'm selling portfolios for 100 Rand, right? I can only get, if I sell 8 portfolios, then my profit must be 100 times 8. It can only be 800. I can't have 800 or something else as a profit. It needs to be exactly that amount. So the input we put in needs to match the output that we're getting. Is everybody okay with that idea? That's why our function can only have one y value for every x value. Okay, and that's what the idea of a function is. So let's go on to the next one. Let's go on to the next one. If we go on to number 2, if we look everywhere with our vertical line test, is number 2 a function? Yes or no? Is it a function? Think of how we're looking at our vertical line test. Yes, 1 point there, 1 x and 1 y value. There we go. I'm erasing things now. There, 1 x value, 1 y value. If we move it over here, 1 x value, 1 y value. So it is a function, right? Number 2 is a function. What about number 3? Yes, if I put it over there, 1 x value, 1 y value. If I move it over there, 1 x value, 1 y value. If I put it over there, 1 x value, 1 y value. Exactly where they cross there. That only gives me 1 x value and 1 y value. Now that one is definitely a function. Let's look at number 4. Is that a function? Is number 4 a function? Yes or no, guys? No, Sanelisa says no. Oko also says no, right? It's not, because for every x value that I find, I'm getting two y values. You see that? I'm getting a y value there and a y value there. That doesn't tell me much about what I'm trying to do with the function. I'm trying to get an input and an output. Now I get one input and I get two different values for my output. No, that's not a function. It's not it's not defined as a function. It's called a relation, but we don't learn about relations in grade 10. All right, let's look at that one. Number 5. Is that a function? Nope, because at any given x value, my graph cuts two places at the same time. All right, so we can tell whether something is a function, whether it only cuts the graph once. All right. Okay. Then we're going to talk about domain and range. Now, domain and range, I'm going to incorporate into the kind of examples that we're doing. But for now, we must know that our domain tells us what kind of x values I have, what kind of x values I have. And my range tells me what kind of y values. I'm just going to go, what kind of y values I have. All right, and we're going to talk about that in a little bit more detail as we go along, because every function that we're going to be talking about and every graph we're going to be talking about is going to give us a different domain and a different range. But we'll talk about what that needs to look like. All right, I just need to check with everyone. Out of 10, are we okay with how to write a function, f of something or g of something or h of something? Do we understand that the x value that we get is the input, the y value that we get is the output, right? And we must define whether something is a function or not a function. Everybody with ma'am here? Okay. Where is that 0,00000000001? I want it, Sia. Tell me where it is so that I can fix it. I want it to be a 10. All right. Okay, let's learn about a specific function. Today we're going to be talking about linear functions. Okay, I don't know what that is. Okay. Okay, so a linear function is defined in the way that we see it over here. Now, I want you guys to note that they could give you a function in two ways, right? They can either give us f of x is equal to something, or they can give us y is equal to something. Both of these things mean exactly the same thing, right? Because the function of x is going to give us a value on our y-axis. And if we just replace that with y, that's going to give us an actual y value. So both of these things do the exact same job. Okay, so if we want to then draw the function of a graph, if we want to see where a graph is defined anywhere, we're going to pick random values. Okay, I like to include in here if x, okay, I need my computer to behave now. If x is equal to 0. Okay, we're going to look at these three. But in order for us to draw any function, okay, I'm going to make this NB. NB. To draw a linear function, I only need 2 points. I just need 2 points. Okay, I only need 2 points. That's all. That's all I need. Because if I can have 2 points, I use my ruler, I put my ruler against those 2 points, I draw a straight line. Okay, so technically we only need 2 points. But let's go ahead and look at the function of each of these if x is equal to that. So we're going to take these three and we're going to use them in this first function. I'm going to call it function number 1. All right. In this first function, we're going to test the values of x is at 1, x at 0, and x at -1. So I want you guys to go ahead and substitute. If x is equal to 1, y will be equal to something. And I want you guys to write it in the form of a coordinate. Remember, your x value will come first, and then whatever value you get for y will come right after it. That's how we express it. Okay, pop your favorite emoji in the chat when you are ready. Okay. All right, peeps, shall we have a look at the answers? Okay, so I don't want us to belabor it. I don't want us to think that it's something beyond our reach. It's not. We're just going to take wherever we see an x, we're going to replace it with whatever value we've been given for x. All right, so I'm going to start with when x is equal to 1. So I'm going to go y will then equal 2 times 1 plus 1. So I know that 2 times 1 is 2 plus 1 would give us 3. So when x is equal to 1, y would equal 3. And if I had to write that as a coordinate for my Cartesian plane, I would first write my x value and then my y value. That's how I need it to look. All right. Then we're going to do the next one. If x is equal to 0, then y would equal 2 times 0 plus 1. Okay, so when x is equal to 0, 2 times 0 is 0 plus 1, 1. Okay, so is equal to 1. So when x is 0, y is 1. Then we're going to do when x is equal to negative 1. Again, we're just going to replace it. If x is equal to negative 1, we're going to get 2 times negative 1 plus 1. 2 times negative 1 will give us negative 2 plus 1 is negative 1. Right, so when x is negative 1, y is also negative 1. So x is negative 1, y is also negative 1. All right, now let's plot these on the Cartesian plane and let's see exactly what it is that we get. Remember, our horizontal is always our x and our vertical is our y. That's our negative x values on that side. And on this side, we have our negative y values. Oish, teacher Coco. Let's do that just a little bit. Okay, there we go. Looks a little bit neater. My OCD is kicking in, guys. Okay, so if we plot these 3 points, I'm going to go to my x-axis and I'm going to look for the point 1. So I'm going to say, there's my x-axis at 1. And my y-axis, I'm going to look for 1, 2, 3, at 3. Then I'm going to draw a vertical dotted line and a horizontal dotted line and a vertical dotted line. That point where these two meet, that is the point 1, 3. Okay. Then we're going to do 0 and 1. My x coordinate in the very middle. This is also called the origin. Okay. It's called the origin because this is where my x value is 0 and my y value is 0. Okay, so when my x value is 0, my y value is 1. So they're going to meet here at that point. Okay, when my x value is negative 1, over here, minus 1. I'm just going to remove this coordinate of the origin. Okay, there we go. So this is negative 1. My y value is also negative 1, which would be down here in the negative y values. So they would meet at that point. All right. So if I now had to draw the function of this graph, it's going to give me a straight graph. It will give me that. And my point would go through all 3 of these. But I will also find that if I went and I looked at where x is equal to 2, the value I would get for 2 would also end up at 5 there on the graph. Okay, if I go look for the point at x is equal to negative 2, I'm going to find that the corresponding y value, which is negative 3, would also end up on this exact graph that we've just drawn. Okay, everybody okay with that? We okay with that idea? We only need 2 points because all the other points are going to end up on the graph anyway. So as long as we can use 2 points to draw the graph properly, all the other points that are involved in creating this function will end up on that graph as well. But guys, I know I'm using whole numbers at the moment. I'm using integers, but that also counts for things like 0.75, or let's call that 0.25. If I put x as 0.25, the graph will also give me a function at the point 0.25. It's going to give me the right value that I need at 0.25. If I choose 0.515, the x value, if that is my x value, my y coordinate is going to correspond to all the values over here. All of them, even 0,99999. If we put 0,999 into my function for x, my y value is going to give us 2,99999, and it's going to correspond because it's going to be on that very graph. All right, that means that my graph is defined everywhere. It's defined everywhere. What that tells me is that my domain, remember what we said the domain is? We said the domain is what values of x can I have? What values of x am I going to have on this graph? If the graph keeps going in that direction forever and it keeps going in that direction forever, what values of x am I going to get? Is there any value of x I will not get? Any value? Any of them? No. Right, I'm going to get every single value for x. That means that x can be any real number. X can be any real number. So when they ask you guys for the domain of a straight line graph, you're going to say that x is an element of all real numbers, because there's not a single value in between any of these numbers that I won't get. I will always get a value. For any x value I pick, I will always get a y value. All right, even if I choose the negative ones, it doesn't matter what it is, I'm always going to get a y value. Right, now if we talk about the range is all my y values. Let's think about it. If I'm getting an x value, I'm always going to get a y value out. So is there any y value that I will not get? Nope. I'm going to get all the y values on a straight line graph. As long as my x value corresponds, I'm going to get a y value. So my range, I'm going to say that y is an element of all real numbers. Any real number that x will give me, y will also give me. Okay. All right, I just need to do a check-in. Is everybody still with ma'am? Give me a thumbs up if you're still understanding everything ma'am is saying, because we're about to learn something called the dual intercept method, which is quite nice. The dual intercept method of drawing graphs. Lovely, Oko. Good stuff, Balisa. Well done. Okay. All right. Beautiful stuff. Okay, that's our domain and range for all. That's okay. It's okay. Do you want to grab some water and see if you need to take a break, if you need to give your brain a break? Do it. Okay, we can always see you on Wednesday. Don't stress it. All right, if you're not with us 100%, it's okay. Okay, guys, if you need to take a break, if you feel like your body and your mind is tired, I'm happy for you guys to take a bit of a chill today. All right. Okay, so we're going to be learning about the dual intercept method. Okay, and that will help us to draw any graph that we need. Now, I want us to be very, very, very clear. The dual intercept method is there for every single function. It's part of every function, but it works best for a straight line function. Okay, so here's what we're going to do with the dual intercept method. We're going to say, if we're looking for the x-intercept, we're going to make y equal to 0. And if we're looking for the y-intercept, we're going to make x equal to 0. Now, this word intercept shouldn't scare us. The word intercept, which is spelled like that, actually, intercept, just means where my graph crosses the y or the x-axis. That's all. Where my graph, okay, my graph crosses the x and y axis. All right, I'm going to use this first example that we've got over here that says y is equal to 2x plus 3. So if we take this example, here's what we're going to say. We're going to say if we're looking for the y-intercept, x is equal to 0. So we're going to go in here and we're going to replace x with 0. So we're going to get y is equal to 2 times 0 plus 3. That means my y-intercept is equal to 2 times 0 will just give us 0 plus 3 is 3. So we're going to go to our y-axis and we're going to put a dot on the y-axis at the point 3. Okay, that's what a y-intercept does. We're going to go, the y-axis at 3 would be somewhere there. I'm going to put a dot there. Let me use a different color. Let's use blue. I'm going to put a dot. I can't see blue. Let's try red. Much better. Okay, that's where my graph is going to cross the y-axis. Then we're going to do the opposite of that. We're going to say we want the x-intercept. And if I want the x-intercept, I'm going to make y equal to 0. So I'm going to go in here and I'm going to replace y with 0 over here. So that's going to give me 0 is equal to 2x plus 3. What am I solving for now in that particular graph there? What am I solving for? Which value?
X.
X. We are solving for x. So I'm going to take 3 and take it over to the other side, and I'm going to end up with -3 is equal to 2x. And then I'm going to divide both sides by 2. Divide by 2. So that means that x is equal to -3 over 2. That is my x-intercept. Right. That means my graph crosses the y or the x-axis at -3 over 2. -3 over 2 is the same as -1.5. So I'm going to go to -1.5 on my x-axis would be on this side. -1.5. -3 over 2 or -1.5. And I'm going to draw a dot. All I need to draw a straight line graph, guys, is 2 values. Now that I've got my 2 values, I can take my ruler and I can join them like that. That's it. Done. That means on this graph, everywhere else, if I choose x to be equal to 1, the value for 1 will end up on this graph. If I choose x to be 2, if I replace x with 2, my value is going to end up on this graph. Okay. All right. So let's do B and let's see how B will look. We'll do B in a different color. Okay. Now we're going to do the exact same thing, guys. We're going to do the dual intercept method for B. So if I want my y-intercept, I'm going to make x equal to 0. If I make x 0, I'm going to get y is equal to 5 times 0 minus 4. So that means y is equal to -4. 5 times 0 is 0, minus 4 is -4. So that means y is equal to -4. So I'm going to go to my y-axis at -4, and I'm going to draw a dot there at -4. Then I'm going to go and look for the x-intercept. So for my x-intercept, I'm going to make y equal to 0. So my new function would then read y is equal to 0. So I'm going to say 0 equals 5x minus 4. And then I'm going to solve for x. I'm going to take my -4 over to the other side. And I'm going to have 4 is equal to 5x. Divide both sides by 5. Divide by 5. Divide by 5. So x is then equal to 4 over 5. So I'm going to then go to my x-axis. At the point 4 over 5, I'm going to draw a dot. Then I'm going to grab my ruler and I'm going to join these 2 lines. And that's it. Any other value that I pick for x, the y value will end up on this line. That's all we need to do. Okay. Are we all okay with how to do the dual intercept method? It's nice and easy because all you really need is 2 points. We only need 2 points for each. Okay, we just need to find where the x, where it crosses the x-axis and where the graph crosses the y-axis. I want us all to try C. Let's try C, guys. I want you guys to use the dual intercept method and find where this function crosses the y-axis and where it crosses the x-axis. So basically, find me the y-intercept. Remember, y-intercept, x equals 0. And find me the x-intercept. X-intercept, y equals 0. All right, and pop your favorite emoji in the chat once you've got those 2 values and you're able to draw a graph with with that for me. Okay. All right, guys, for the sake of time, because we've only got like a minute and a half left, I'm quickly going to go through this one. And guys, just double check and see if your answer looks like mine. All right, so I'm going to rewrite the function over here. Y is equal to x minus 3. Right. So I'm going to say I want the y-intercept. Therefore, I will make x equal to 0. So I'm going to have y equals 0 minus 3, which is equal to negative 3. So my y-axis will cross at negative 3. So, or my graph will cross the y-axis at the point negative 3. Okay, then I want my x-intercept. So x-intercept, I'm going to make y equal to 0. Right, so I'm going to say 0 equals x minus 3. And then I'm going to take the negative 3 over to the other side, and it's going to become positive. So I will have 3 is equal to x. So my graph will then cross the x-axis at the point 3, positive 3. So I'm going to go there to positive 3. And then I'm just going to take these two and join them with a ruler. Okay. That's all. That's all we're going to look at today. All right.